Hi guys, welcome to this video session. In this video, we are going to see about the working principle of electron beam welding and laser beam welding. Electron beam welding. It is a fusion welding process in which a beam of high velocity electrons is applied to the metals to be welded. The kinetic energy of the electron is transformed into heat, and this heat causes the metals to weld. The working principle of electron beam welding is explained through this animation.
Tutorials. In this video we will learn electron beam welding process, the main parts, and functions of different parts of an electron beam welding setup. So, let's get into the topic. We know that welding is the process by which generally two or more parts of metals or thermoplastics are joined together or united together by either applying heat, or by applying pressure, or by applying both heat and pressure. In electron beam welding, this joining of parts will be obtained by applying heat. And by the name electron beam welding, we can understand that we will be using electron beam to generate heat, and create the welding joint between the parts using this generated heat from electron beam. So, let's look into the working process and major components used in electron beam welding. Here we have a power supply that will run the entire process. This electron beam welding process uses a continuous power source to supply power for continuously generating beam of electrons throughout the welding process. The voltage range of welding is about 5 to 30 kilovolts for low voltage equipments or for thin welding, and 70 to 150 kilovolts for high voltage equipments or for thick welding. To start the electron beam process, the first thing we need is something that will generate the electrons. So, here we have an electron gun. This electron gun is the heart of electron beam welding. It is a cathode tube with negative pole, which generates electrons. This electron-generating cathode tube or electron gun is mostly made by tungsten or tantalum alloys. Now, when power supply is provided to this negative charged cathode tube, the cathode filament is heated and generates electrons. The cathode filament is heated up to 2500 degrees centigrade for continuous emission of electrons. Now, when electrons have been generated, we need to increase the velocity of electrons for the welding process. For increasing the velocity and accelerating the electrons, we need to create a potential difference between this cathode and an anode. So, here we have an anode, which is a positive terminal. When power supply is given to the anode and the cathode, then a potential difference of around 30 kilovolts to 175 kilovolts is created between this anode and cathode. Due to the potential difference created between these two terminals, the anode accelerates the electrons coming from the cathode and forms an electron jet. So, this anode is a positive pole which is just after the electron gun. Its main function is to attract negative charged electrons generated from the cathode, accelerate these electrons and provide them a path so that they do not diverge away and can be focused together in towards the next components. Now this accelerated and high-velocity electron jet will go past the anode and reaches the focusing coil or focusing lens placed here. When electrons are coming through all this way from the cathode and passing through anode, with increasing distance from the source, these high-velocity accelerated electrons will always try to diverge away from one another. But for welding process we need to bring all the electrons focused on one line or one point to get the desired amount of heat to produce joint. Now, just like a convex lens or converging lens which concentrates or focuses all the entering dispersed light rays to one point. Almost similarly, here we have a focusing coil or focusing lens that prevents the incoming high-velocity accelerated electrons from dispersing away, and gives a focusing path to these electrons. The accelerated electron jet will now follow this focusing path and move together. Now, on this path here we have a deflecting coil. This deflecting coil deflects the beam at required weld area on the workpiece where we need the welding joint to take place. Here, we have the workpiece or the parts that are to be joined. There is a fixture down here on which the workpiece is fixed firmly so that it does not move during the welding operation. This welding operation takes place inside a vacuum chamber. The workpiece fixed on the fixture is placed inside this vacuum chamber. When this deflecting coil deflects the beam, this high-velocity accelerated electron jet enters this vacuum chamber and concentrates on the point where the beam is deflected to create welding on workpiece. What actually happens at this point on workpiece is that, when highly accelerated electrons with kinetic energy will concentrate and hit on this point of the workpiece, then the kinetic energy of these electrons will convert to thermal energy and produce heat. This heat will fuse and melt the metal workpieces and create a joint or welding between them. This vacuum chamber is created surrounding the place of welding, so that the electrons do not come in contact with air, and we can utilize the maximum penetrating power of these electrons. Welding would take place even if this vacuum chamber was not created, but in that case these deflected electrons would come in contact with the air and deviate in some proportion from their original path. As a result, the electrons would get scattered, and instead of getting a concentrated beam on the place where we need to make the joint, the beam would cover a larger area on the workpiece. As a result, the fusing area or melting area on the workpiece increases more than our requirements, and we wouldn't get a perfect joint. This is why we need to use a vacuum chamber, so that when this highly accelerated electron beam passing through all these components comes into this chamber, then the beam doesn't scatter and a proper joint is obtained. Now, since the welding is done on a vacuum-sealed chamber, it is not possible to manually move the workpiece from one position to another when one position has been joined. Thus we need to control the positioning of workpiece from outside the vacuum chamber using computer numeric controls. So, this is how electron beam welding process works. Thank you for watching this video. If this video was helpful, subscribe.
Now, these following clips explain how electron beam welding takes place in real time in industries.
In electron beam welding, the coalescence heat is generated by the kinetic energy of a focused stream of electrons directed upon the joint. The electrons are produced by an electron gun, accelerated to high velocity, shaped into a beam by electrical fields, and then further collimated or made parallel and focused by an electromagnetic lens. This electron stream is developed in high vacuum, but actual welding can be performed in either high vacuum, partial vacuum, or standard atmospheric pressure. Because of the intense and concentrated heat generated, total heat input is low, minimizing heat-affected zone size and part distortion. This also allows for the creation of extremely deep and narrow welds. Additionally, joints inaccessible by other welding processes can be welded. Virtually all ferrous and non-ferrous metals, thin or thick, can be joined. Welding speeds are fast, and filler metal is not generally required. Equipment cost for electron beam welding is typically high, and welding is generally limited to machined parts assembled in primarily butt, corner, and lap joints.
Advantage of electron beam welding. It's a tight, continuous welding process. Load distortion takes place. It is used even for narrow weld, and it causes narrow heat affected zone. Filler metal is not required for this welding process. The disadvantages are, it is highly expensive equipment, causes for X-ray irradiation. Laser beam welding. It is a type of fusion welding in which a beam of laser is used to join the metal to be welded. The following animation shows the working principle of laser beam welding.
A laser is produced when the electrons in atoms of special crystals are energized using electric current. Generally, garnet crystals are most commonly used in solid-state lasers. Yttrium, aluminium garnets, and doped with neodymium, which is also called NdYAG, are most popularly used. These excited electrons emit photons. Photons are the particles of light, and these emitted photons form a concentrated beam of light, forming a laser. As the laser beam strikes the surface of the workpiece, the heat energy from the laser beam is transferred to the workpiece. This heat energy absorbed, melts and vaporizes the material from the workpiece surface. Construction. The laser beam machine consists of following parts. Power supply. It requires the power supply of 1 to 10 kilowatt. A high voltage power source is used to produce light in flashlight tubes. Flash lamp. Flash lamp or flash tube is used to charge the electrons of the atoms in the crystal, which is also called as pumping medium. Capacitor. Capacitor is used for operating the laser beam machine in pulses. Pumping medium. Pumping medium in this case is a ruby crystal, which has a large number of atoms, which when absorbs the energy, their electrons produce photons. Working. When the switch is turned on, a high voltage power supply is applied across the flashlight or flash tube surrounding the pumping medium, in our case it's ruby crystal. As the light is powered on, it emits high energy photons. These photons are absorbed by the ruby crystal. This absorbed energy causes most of the electrons contained in the atoms of the ruby crystals to be excited at a high energy level from its ground state. After a short duration, as the electrons from high energy level comes to ground state, they emit photons. This emitted photon stimulates the excited electrons to return to their ground state, thus producing more photons as they return to their ground state. Thus a pair of photons are obtained by utilizing one photon. Thus, we call this process as amplification of light using stimulated radiation. As the photon's concentration increases, the laser is formed. A 100% reflective mirror is used to reflect all the photons back to the crystal, whereas a semi-reflective mirror reflects some of the photons back, and escaping photons through a semi-reflective mirror forms a high-energy laser beam. Then a lens is used to focus the laser beam onto the workpiece to be machined. Interaction of laser and workpiece produce a large amount of heat, thus vaporizing the surface of the workpiece, thus cutting grooves of various shapes, or cutting the workpiece.
This is how the working of laser beam welding takes place. The advantage of laser beam welding are it requires minimum heat, so minimum heat affected zone happens. No electrodes are required for this type of welding process. Tool wear are eliminated and it can be used to weld small areas as well. Two dissimilar metals can also join by using laser beam welding. The disadvantages are joint must be accurately positioned. That means proper fixture is required for this. Maximum thickness of welded joint is limited for this type of welding process. Thank you.